Good afternoon. My name is Jack Bacon. I am with the NASA Orbital Debris Program Office as the safety lead. My co-author on this paper is Dr. J.C. Liu, who is the NASA Chief Scientist for Orbital Debris and the chairman of the group that created the new U.S. Orbital Debris Mitigation Standard Practices. This presentation is more of a public service announcement than a technical presentation, and it is to orient you to the new set of standards that will apply whether they come from NASA, the Department of Defense, FAA, FCC, or any other U.S. licensing agency. We expect that many of these new practices will also become international standard practice through our cooperation with the Interagency Debris Coordination Committee. A little bit of history for you. The NASA Orbital Debris Program Office was founded in 1979, and within a decade, the problem of orbital debris had become a priority in the national space policy of Ronald Reagan. It has remained a top priority in our space activities since, and by the year 2000, the US government, in implementing its standard practices and working internationally with our partners in most spacefaring nations, had been able to curb the generation of new objects in space. So if you look in particular at the fragmentation debris, which is the pink line in this chart of counts of objects, you'll see that beginning around the year 2000, it very much leveled off until the Iridium Cosmos collision and the unfortunate Fengyun 1C orbital debris test. However, you will notice that the count of objects has recently started to rise, largely due to the CubeSat population here at the far right of the curve in the blue line. So additional objects are starting to show up. The key to take away, though, is that the fragmentation debris grossly outnumbers anything else we put in the sky. So our priorities here in the orbital debris mitigation standard practices is to keep the functioning spacecraft and rocket bodies from self-destructing or colliding with anything. The count of mass in orbit, even despite the very large fragmentation increase, is only smoothly growing, and that has to do purely with the number of spacecraft we put up. You can see that the pink line, which is the fragmentation debris, is a very, very tiny fraction of the mass, and yet it is most of the risk to functioning spacecraft. So spacecraft and boosters account for the vast majority of the mass in orbit. That mass can be melted down, cut apart, and turned into bullets that we cannot track, and every one of those bullets is dangerous to another spacecraft. The amount of debris up there that can disable a spacecraft is growing exponentially. I will point out that one 1U CubeSat in a hypervelocity collision will create between 34,000 and 65,000 objects that can disable any other spacecraft in the sky. Therefore, it is of paramount importance that every spaceflight participant make sure that we do everything we can to avoid creating fragments out of our spacecraft. Now that involves not releasing any debris, not becoming a bullet that can hit anything else, and certainly trying not to be a target that can be shattered by some other piece of debris. The new standards reflect these practices. Space Policy Directive 3 came from the Trump administration in June of 2018 and directed all U.S. agencies to update the policies that have been in place since 2001. All of the standards to which you have had to comply so far derive from that original 2001 document. The 2019 update reflects a year and a half of work chaired by NASA. Dr. Liu, the co-author of this paper, was the chairman of that operation. And it reflects the input of all U.S. agencies in response to the growing amount of orbital debris, the new types of activities going on, and you will find that these new standards flow to the policies, standards, and licensing practices that you will need to adhere to within the coming years. So there are 9 charts here to outline what's new in the orbital debris standard practices. First, we need to make sure, as always, that your mission does not generate a lot of sub-pieces. So we would prefer that your satellite does not generate a lot of little things coming out. We are aware that there are certain microsatellites that you are designed to deploy. The new requirement is that there are less than 100 object years in space from everything that your mission puts out. So if you put out 100 small objects, they all have to be in the atmosphere within a year. Um, so the generation of accidental explosion fragments, this is paramount. We do not want you to autonomously destruct. And it turns out that most of the fragments that we count in space are a result of such self-fragmentations. The stored energy on board the spacecraft, whether it is propellant or batteries, sometimes momentum wheels, can actually, if gone unstable, can cause the disintegration of the spacecraft. So without hitting anything, many of the spacecraft in orbit actually self-destruct and become many hundreds to thousands of fragments. So we require that there's a 1 in 1,000 chance that you will actually explode as a result of release of stored energy. And lest you think that it is not possible, just understand that it happens all the time. And we see this happening to spacecraft every couple of months. Certainly, we do not want you to become a bullet. We don't want you, as a functioning spacecraft, to collide with something bigger. That would be the worst possible scenario. We ask for a 1 in 1,000 chance that you do that. Certainly, if you can do active debris maneuvers to get out of the way of spacecraft, that helps. Unfortunately, a lot of times we don't see these things coming. So we are still counting very heavily on the low population of things in the sky, the big sky theory, but still 1 in 1,000 doesn't always work. Limit collision with small micrometeorite and orbital debris. I know we can never see this coming. This is pure statistics. However, your reliability of disposal to get out of the highway when you're done. There's certain reliability requirements for you to perform the maneuver, but if you do have such functions, then we need to have a less than 1% chance that you will collide with something that could disable such things. So we will statistically look at the size of debris that could disable your power system or your thruster. We need to count that up and figure the probability less than 1% that such collisions would actually disable your spacecraft. This is over and above the inherent reliability requirement of 90% that your system works to get out of the sky. The 25-year rule is being updated to possibly mandate, particularly in some of the licensing agencies working with the very large constellations, that we may need to do this faster. So the 25-year rule has been a good balance between cost, particularly the fuel requirement, and the benefit of getting things out of the sky. However, we are now encouraging operators to get out of the sky immediately, if at all possible. We would prefer just to not have you be a target terribly long. Post-mission disposal, therefore, is really the big idea here. We need less objects for a shorter period of time than we have classically been generating. So with more objects being put up, we are really focusing on trying to get those targets out of the sky. Post-mission disposal storage out of the way of the main operational belts, which are the LEO environment, the semi-synchronous environment, and the GEO environment. We have several policies that affect trying not to either enter those zones, or if you have to enter them as a function of the ballistics of your mission, that over the next 200 years, you can accumulate no more than 25 years coasting within these operational zones. It's very similar to the 25-year disposal rule, but over the next 200 years, we would like you to stay out of those operational zones. Certainly permanent storage above GEO, then you need to get above 200 kilometers above the operational zone for the next 100 years, and that includes perturbations that are brought to you by lunar tug, the third body problem that can perturb your orbit. The long-term reentry is actually looking at the possibility that in highly eccentric orbits, we can use the third body tug of the moon to elongate the orbit and drop the perigee into the ocean. This is not true of every possible right ascension on every day that you can launch, but long-term planning for this disposal option will certainly help to clear things out of the sky. This is absolutely a new feature in the upcoming standards. Also a new feature is the direct retrieval option. This acknowledges that active debris removal and satellite servicing are coming. We therefore expect that many operators may elect for this to have someone else get you out of the sky. This is fine. However, we prefer in the new standard that this removal operation occur within 5 years of the completion of the mission, so that you're not parked there waiting for a better deal on getting out of the sky. The reliability for your own post-mission disposal, whether you are going to be receiving an active debris removal system or propelling yourself out of the sky, your part of that deal has to be at least 90% reliable. That is a holdover from the prior missions, prior mitigation standard practices. 90% reliability is achievable, and we would like to see all spacecraft operators to reach that kind of level of design, no matter how long your mission is, that your end of mission reliability is at least 9 out of 10. New things coming for large constellations, in particular, the 25-year rule is probably going to be enforced trying to get out of the sky immediately. And in addition, the post-mission disposal reliability, while it is not absolutely mandatory, it is strongly encouraged that particularly if you have a large fleet, that every member of that fleet achieve the 0.99% reliability of disposal. So we're another order of magnitude less likely to fail in the post-mission disposal operation. And this imposes some severe quality assurance and reliability requirements on large fleets. I would expect that one or more U.S. agencies will actually make that mandatory. Small satellites, including CubeSats, as we said, even a 1U CubeSat can generate more fragments than there are functioning spacecraft in the sky, and therefore there are no exceptions. We are aware that the small satellite community is looking at sub-satellites. The 100 object years requirement is going to apply, and we very much wish that you maintain a limited number of objects for a limited number of time in orbit, no matter what your mission design. So the key new elements of the ODMSP include the rendezvous and proximity operations of satellite servicing, that more and more we're seeing spacecraft approaching each other, contacting each other. If you are doing satellite servicing, almost certainly you are dealing with the energetics of the spacecraft that you are servicing, whether that is the propellant or the battery system. Something mechanical or pressurized or chemical is going to need some sort of work. And anytime you mess with the energy system of a spacecraft, you risk the chance that it will lead to a conflagration or explosion. Therefore, these will get special scrutiny. Certainly the rendezvous and prox ops don't hit it, but even while you are servicing it, the generation of debris from clipping wires, from cutting away caps, replenishment, fuel leaks, all of this will be getting special scrutiny in the satellite servicing. A subset of that is the active debris removal operations. Again, don't collide with it. So if you're coming up and making contact with a spacecraft, all of this has the potential to create fragmentation debris. So active debris removal, satellite servicing will be getting special attention because in many cases these spacecraft weren't designed to be tinkered with. And as an aging system, they will be subject to special safety scrutiny. In addition, beyond the orbital debris mitigation standard practices, since 2015, the 18th Space Wing of the Air Force, also known as JSPOC and CSPOC, they have had available to the owners and operators of satellites the recommendations for optimal operations. They're not mandatory. However, we're finding that compliance with these recommendations has been poor and has actually led to some serious confusion in trying to figure out who's who in the sky. I was aware at last year's SmallSat conference that there were several owner operators that declared that they knew which of the 60 satellites from a SpaceX launch or the 104 from the Indian launch were theirs. But they hadn't communicated that to the space wing. And that leads to all kinds of problems if they're trying to positively identify the details of the design and whether or not there's a potential collision if the owner operator has the option to, for instance, change the drag to avoid collision. All of this is in the future. They would really like to coordinate with you better to know who's who in the large constellation. So we have evolving new rules. They're very similar to the traffic rules. I encourage you to read this slide because we're running out of time. But basically, if you're driving the car, don't park it in the middle of the highway. Don't shed debris. Don't dump your load. Try to make sure that your car is very reliable and isn't going to break down. All of these make sense. We're just applying these to space traffic. In addition, please follow the CSPOX 2015 recommendations. The orbital debris mitigation standard practices includes improvements over all aspects of space operations, and you can expect to see them very soon in your licensing and standards. Thank you very much for your attention.